Okay, so now what we are going to work on is we are going to work on the quotient property of logarithms. Okay, so the quotient property. The quotient property tells me that if I take a logarithm of any base, let's say it's x, and I have two parts divided on within my logarithm, that's the same as if I take that log base with that same base and then a, and then I can subtract it by log base x of b. Okay, so this is what I'm going to try to prove here right now for you, help you give you a little better understanding of maybe where these properties are coming from. So let's just start by just defining some stuff. So if I say that, let's say x to the L power is equal to a, that means that log, base x of a is equal to L. Okay, let's go ahead and say x to the m power is equal to b. And so that would mean that my logarithm base x of b is equal to m. And then let's go ahead and set up the third one. Let's say x to the n power is equal to a divided by b. And so that means my logarithm base x of a divided by b is equal to n. So let's go ahead and dive on into this. So let's go ahead and look at, well, I know that x to the n power, let's just look at a divided by b. I know that a divided by b is the same as, well, what is a? A is the same as x to the L power. And what is b? B is the same as x to the m power. Okay, so all I'm doing is just using a little bit of substitution to say that, a divided by b is equal to x to the n power, but it's also equal to x to the L divided by x to the m. So let's actually write what I just said, right? A divided by b is also the same as x to the n power. So now I know that x to the n power is the same as x to the L power divided by x to the m power. Okay, so then you're going to need to know a little bit about your exponent properties, specifically when you have the same base as we do here, and we are dividing, where we can actually just go ahead and keep the base. So let's go ahead and keep our base, x, and you would subtract your exponents. So this is going to be L minus m. Okay, and so again, as you saw in the product property proof, we know that if these bases are the same and they're equal to each other, these exponents are going to have to be the same. So I now know that n is the same as L minus m. So let's just go ahead and do a little bit of substitution. I know what L is equal to. L is actually equal to log base x of a. So log base x of a, and then minus m. M happens to be log base x of b. And that's all equal to n. Well, n is also equal to this logarithm base x of a divided by b. So that's equal to log base x of a minus log base x of b. Okay, and actually right there, that's the quotient property. So quotient property says if I have a logarithm with a base and I'm dividing, I can really just split up the logarithms with two separate logarithms and subtract them, just top minus bottom. Or if I have two logarithms with base of x and I'm subtracting them, I can push that into one logarithm with the same base, as long as these bases are the same, but just divide a over